So recording is started. Complete this table. Okay, another 30 seconds. Okay, so we had talked about verbally, this is multiplying x by 5, and the inverse is dividing x by 5. So the x gets divided by 5. This is adding 2 to x. So this is, you can think of it as a function. There's a one way, it's kind of nifty to think of functions. Now as an x goes in, and there's a step to it. Add 2. And what comes out is x plus 2, and this is my function f. And so you could think of it as a stretching machine. Something comes in and it gets stretched, and it's now 2 units longer than it was when it went in. And then the inverse of that would be a compressing machine. It makes it 2 units shorter than it was. And so if you send a piece of Play-Doh in to both machines, it winds up getting it back to where it was. And cubing, the inverse is cube rooting. Dividing by 4, the inverse is multiplying by 4. And if it doesn't do anything, the inverse doesn't do anything. It looks like this. Alright, a little feedback on completing this table. Is it coming all back? Was it you needed to shake off the rust? Alright, so let's go. Let me switch you over to here. So, number 2. Do this one when you rent a bike. It costs a flat fee of $6 plus $2 per hour. X represents the number of hours a bike is rented. Create a function which represents total cost of renting a bike for X hours. Find f of 7 and so on. Continue on with this as far as you can. I'll give you a quick minute and then I'll give you a little bit more time. Okay, 30 seconds more. Alright, so I'm going to start actually with f of 7. If I rent, that would mean I rented the bike, see, x is hours that you rented the bike, and y or f of x is the cost. And if you rented a bike for 7 hours, you have the flat fee of 6 just once. you have the per hour fee of $2 7 times. So this becomes 14, and you add them together and you get a $20 cost to rent a bike for 7 hours. That kind of gives me an idea for the f of x. I know I'm going to have the $6 fee just once. The $2 fee, well, if I rent it for x hours, it's going to be 6 plus 2x. Alright, and give me a little feedback on A and B. Particularly, I'm interested, were you able to come up with the function f of x? Because I'm not just sure where everybody's at. We haven't really practiced that kind of a thing. Okay, and sometimes it's hard to admit when you can't do something. But that's very helpful information for me. Okay. And, all right. I'm going to give you a little bit more time with C, D, and E now that you kind of confirmed that your answer was right for the function. Okay, 30 seconds more. All right, on C, the $26 doesn't go in for the x, because that's hours. It goes in for the f of x. So if your total cost was 26, how many hours did you rent the bike? You don't have to solve this through an equation, but you can. Divide by 2, x is 10. So it was $20 for the per hour fee. It must have been 10 hours. Now, we're just getting into these inverse functions. How do I come up with the inverse of something like this? Well, the table we were looking at a minute ago, the inverse of multiplication is dividing and so on. We can see how to invert when we have one. When we have more than one, we had a practice quiz the other day. Let me zip up to that. No, it wasn't in the practice quiz. It was in the start of the section. Yes, when you had more than one action. Entering a room and turning on the lights. We had to invert each action, and we had to invert the order. So the last thing that was done had to become the first thing that was done. Turn off the lights, leaving the room. So there's a plus 6 and there's a multiply by 2. My f inverse of x, two ideas come to my mind. Subtracting 6 and dividing by 2. And the other idea that comes to my mind is both subtracting 6 and dividing by 2. But notice these are rather different. One of these two is correct, and one of these two is not correct. And it depends upon the order in which. Now, how do I tell which one is right and which one is not? Well, let's go to E for a moment. E says F inverse of 26. What does the inverse really mean? The inverse really means this is the output, and find the input that went with that output. Normally, when you have F of 7, that's an input. And that's 7 hours, and this is the cost. That's the output. But when you have the inverse function, it just reverses their roles. So it's saying that the cost was $26. And it says, find the number of hours. Well, we already know that. It's 10. So F inverse of 26, we already computed that. It's 10. All right, let's look at, do we get 10 if we put 26 in each of these two functions? Let's put 26 in here. You get 13. 13 minus 6 is 7. And we don't get 10. So this is not the correct inverse function. Well, let's put the 26 in here. I'm going to get 20 divided by 2 is 10. This is correct. This is the correct inverse function for this one. All right. Give me a little input on parts D, C, D, and E. Okay, thanks for your honesty. Okay, bit confused, a couple people getting a little clearer. We're going to go over these inverse a lot more. This is just kind of getting started with it. Okay, and all right. So describe the inverse function, f inverse of x, through the questions below. What does the input represent? What does the output represent? What would be the usefulness? So, represent has to do with these things, the cost, the dollars, and so on. So, let me put it so you can see. Trying to get it as big as I can, but you can still see. There is the original. What does the input represent? What does the output represent? And then I'll scroll down in a minute to part 3. And then what's the usefulness of the inverse function? Okay, 30 seconds more. Okay, let me have you stop. So always look at the original function. X was the hours, y was the cost. The inverse function just goes from the opposite. It goes cost to hours. It just reverses the role of the input and the output. And so the function, what's the usefulness of the function? Well, that's very useful for a person who's, charging people for bike rental. Oh, you rented the bike for 10 hours, so it's going to cost you $26. What's the usefulness of the inverse function? It's to find the number of hours. The number of hours. You can rent bike if you only have a little money. Or, you decide you only want to spend this much. So, I only want to spend $26. Or I only have $26. How long can I rent the bike for? I can make sure I'm going to return the bike by 10 hours. Give me a little more feedback. This feedback process is also important with you're kind of putting some things in words. It's like if you can put it a little bit into words of what it is, you're coming to understand a little bit better. That's tricky, but very useful. Okay, so inverses, it kind of depends on how you look at them, what they are. It's like climbing up a ladder, climbing down a ladder. Completely undoes the function, as if nothing had ever happened. But it also just kind of reverses the order of things. Instead of inputs to outputs, it takes what was the output and sends it back to the input. Okay. Let's go to practice quiz for the next one. There's a graph for what intervals is f increasing and decreasing. Okay, 30 seconds more. Okay, if I say, let me take an interval along the y-axis, from y being like negative infinity up to 2, then it's increasing, it's going up. But this can't be right, because it's also going down in that same interval, same heights, from negative infinity to 2. We can't do intervals along the y-axis. You have to pick your interval along the x-axis. Now, the quickest, easiest way to state this is x. You don't have to put from negative infinity. You could say just x is less than negative 1. But if you were writing it in interval notation, It didn't ask you to do it, but if it did, you would write it from negative infinity to negative 1. Now we don't include the endpoint of negative 1 because right there it's transitioning. It's neither increasing nor decreasing. It's kind of horizontal. It's just like your stock isn't gaining money, it isn't losing money, it's just holding steady for a little bit. Okay. For what interval is it decreasing? Is, if this was stock, it'd be decreasing from x greater than negative 1, or in interval notation from negative 1 to infinity. Okay. Give me a little feedback on A and B. Okay, we are getting kind of feedback on both extremes. Some find this really simple, some find it very confusing. Okay, hopefully, well, let me offer this too. If right after class today, if you want to stay for a little bit longer and work on a couple more of these, I'll stick around. You'll have to remind me. I tend to forget things right after class. But if anybody wants to do that and is confused on this, I'll be happy to give them some more problems and give them some feedback. And all right, Valerie, great, and remind me right as class is finishing up. I'm terrible about forgetting things like that. Okay. All right. So state the domain, state the range. Now I'm going to put the graph again over here. So, all right. So looking at this graph, state the domain, range, and answer all these questions C through G. "30 seconds more." Okay, so the domain is always a statement about x. What must be true about x? We could say, well, how far left, how far right. X can be any real number. And a shortcut notation for that is this, and in integral notation it would look like this. So all these are acceptable answers. The range, if I said, what input has a height of 3? Well, not 3 can't be but you know, all the x's could be there, but not all the y's. So where are they from? Y must be less than or equal to 2. That's the highest height you can never get. Or you could put this in interval notation from negative infinity to 2. Find f of 1. We just look at 1 and we say, what's the corresponding output? 2, negative 2. And then find all values of x, where f of x is equal to 1. Now this one, the output is 1. So you're taking this horizontal line that has a height of 1. And you're saying, what are the inputs that will give you this output? And x could have been right here, negative 2. And x could have also been 0. 2 inputs lead you to that output. You never have that vice versa. You never have you cannot have it violate the vertical line test. So one input can't have 2 different outputs, but you can have 2 different inputs both having the same output. Okay, and then sketch this. Well, we have to know, what does this cause to happen? It causes me to shift 2. It's a horizontal shift. Horizontals go opposite direction of the sign, so it's 2 to the left. And this causes me to go 1 down. So vertical shift happens in the same direction as the sign. So if we do that, I'm going to just take one key point, the vertex. That vertex, I'm going to shift it to the left and 1 down, and it's going to be right here, and then here's my new. My parabola should look same basic shape, but shifted to left and 1 down. And give me feedback on C through G. All right, you've got on Wednesday is exam number 1, and I was checking right before class, in the grade book, exam 1. The practice exam 1, and we got, most people have got this turned in. Okay, so the before Wednesday's class at 12:30, so what opened up today at 12:30 was the solutions. And so go into the modules, you'll see the solutions, correct your own practice exam. All the ones that you got anything wrong, you need to make changes and then upload those changes into exam 1 with practice exam 1 with errors corrected. And that's also worth a homework grade as well. And we are going to go now to let me just look a little bit more at this feedback. Got these. All right. We're going to go back to inverse functions, and we're going to continue on with this. This section on inverse functions is going to be on the exam. So you got to get this assignment in, 3.7, get that in before the exam on Wednesday. And before I move on though, any questions up to this point? Any questions about the exam? Any questions on any previous homework problems? All right.
I do. Sorry.
Yes.
It's Nadine. Can you go over? I don't know why I'm still struggling with problems like number 10 on the practice test exam.
Number 10 on the practice test. All right.
Yeah, and yeah.
So let's go and practice exam. All right. This is what just opened up today. So let me go, and then it says here are the answers. And let's look at number 10.
And it's more so C and D that I'm struggling with.
The B and the D. Okay.
C, letter C as in cat, and D as in dog.
C and D, the composition ones.
Yes,
Okay.
sir.
The little circle is the composition. And so the way we do that here is we rewrite in exactly the same order, and that's called nested parentheses, f of g of x. And then, now, the g gets done first. The g is 3x minus 1. And that 3x minus 1 is going to get thrown into the f of x function. So it's going to be 5 times that 3x minus 1 squared plus 2. And then when you square that out, you have to FOIL it out. It becomes looking like this. Now, did you say your name was Amy? So I thought I heard you say.
Nadine. Sorry, Nadine Salazar?
Nadine. Okay, Nadine. Okay.
Yes, sir.
And Nadine, does that answer your question on C?
Yes, it does. I just struggle in putting them in the right order.
Ah, okay. Like, what might help with that too is, you see, like this was done all in one step. And an option, instead of doing it as all in one step, is, these are the two functions. Take them over here. Get a little space. Okay, so f of g of x is, if I do just one at a time, and then I write out what does f really mean. So I plug
Yeah, that helps
this
a lot.
in there. And then so on from there. Okay?
Thank you.
You're welcome. And all right. Any other questions? All right. If no other questions, let's move on from inverse functions. When there's only one operation, you should be able to intuitively get the inverse function. It's just kind of like the opposite. Dividing by 4 makes something 4 times as small, so multiplying by 4 makes it 4 times as big. This stuff should all make sense, and you don't need any help getting the inverse function. You don't need a procedure to follow. But when the functions get complicated, we would be really helped if we had a foolproof procedure. One of the practice quiz problems today was over here when we said, this just had 2 steps, multiplying by 2 and adding 6. But which order do you put them in? It takes a lot of focus to figure that out. Well, fortunately, we don't have to even think about it. We have a foolproof procedure that will get us the correct inverse no matter how complicated the original function is. Now, this foolproof procedure, oops, I went to the wrong one. This is both the strength and the difficulty of mathematics. Mathematics turns very complicated ideas into what can sometimes be called mindless procedures to follow. And you follow this procedure mindlessly and it'll get you the right inverse function. And the problem is that sometimes it's actually done mindlessly and we lose sight of the big picture, and we know that really to understand math you have to be able to do more than just follow the mindless procedure. You got to know what it means and why you're doing it and so on. So it's kind of neat how it gets into the very nature of what mathematics is and how it works. All right, let's go. A foolproof procedure. The function f of x equals 4x cubed minus 3. There's 3 operations that happen to an input. Suppose I told you that x was 10. How would you find f of x? Well, first of all, you'd raise that 10 to the 3rd power. That has to happen first. And then you multiply by 4, that answer by 4. And then finally you subtract 3 from it. So 3 different operations. Our foolproof procedure for generating the inverse function, f inverse of x, must invert each operation, like changing that multiplying by 4 into dividing by 4. And then also, since there's 3 different operations, it must reverse the order of the operations. So for instance, if x was 10, the very last thing we'd be doing would be subtracting 3. But that's going to be the first thing we're going to do, because it's going to, when we do the inverse and add 3, that's got to happen first. So we got to reverse the order. Now the claim is that the 3 steps below is the foolproof procedure that will force each operation to get inverted, and it will reverse the order of the operations. And these are the 3 steps. And the key step of these 3 steps is this one right here. And these, it always happens. This renumbers my things. This is step number 1. This is step number 2. This is step number 3. Step number 2 is the step that's really going to be doing the work. Right here. All right. We're going to follow these 3 steps with f of x equals 4x cubed minus 3. So let me just ignore all this stuff for a moment. Let me put this down again down here. F of x is 4x cubed minus 3. Now, we're going to do step 1. Interchange x and y. And what's assumed is that f of x and y are the same thing. So replace f of x with y. And now interchange x and y. Now interchange means every time you see a y, write down an x. Every time you see an x, write down a y. If there were multiple x's over here, each one of them gets turned into a y. So we interchanged x and y. Now, after we interchange the x and y, the next thing is, this is going to be doing all the work here. We're going to solve for the y. Now when I solve for the y, remember what I said a little while ago. If x was 10 and you were trying to find out f of x, you'd have to cube it, multiply by 4, and finally the last thing would be subtracting 3. Well, when we solve for y, what's the very first thing that we're going to wind up doing here? We're going to do the opposite of subtracting 3. We're going to add 3. So the first thing that's going to happen to the x is the opposite of the last thing that had happened in the original function. And so it's doing exactly what I'm claiming. It's going to invert each operation. The subtracting 3 became adding 3. And it's going to reverse the order of the operations. The minus 3 would have happened last, but now that happens first. All right? Then the next thing. If I'm going to solve this for y, I'm going to divide both sides by 4. Can't cube root first. I have to divide by 4 first. Get the y cubed by itself. Now when I do that, I'm going to turn it around. I'll put the y cubed first. I'm going to put x plus 3 divided by 4. So notice the multiplying by 4 got turned into dividing by 4. It inverted each operation, but it's also reversing the order of things. Now, if x had been 10, what's the very first thing you would do if you were finding f of x? You'd cube it. Well, we're going to cube root both sides, and that's going to be the very last thing we do. So it's really reversing the order of things. So now I'm going to solve for y. I cube root both sides. And then I'm going to get y equals the cube root of x plus 3 over 4. So this step right here is where all the work happens, solving for y. The last step, replace y with f inverse of x, is just so that we know what we're talking about. The y, this is really the inverse function. Oops. F inverse of x is this function. All right, now, without looking at your notes, see if you can write down the 3 steps. The foolproof procedure for finding an inverse function. Write down, from memory if you can, what are the 3 steps. Okay, and those 3 steps are interchange x and y, solve for y, replace y with f inverse. And that will get you the inverse function. No matter how complicated, sometimes functions are really intensely complicated, but we don't have to worry about which one came first and how do I do it. This procedure always gets us the right inverse function. Any questions? All right, so I'm going to have you practice, do some problems. So A. F of x is 3x minus 2 divided by 5. I'm going to have you find f inverse of x by using the three-step procedure. But we are at a break time, so let's stop right here. We will start again at 1:31 p.m. And when we start, then I'll go through and do mine. So if you want to work on this for a quick minute before you take your break, and then when we start up, I'll put my answer for that. And before I take my break, anybody need to talk to me individually? All right, see you in a bit. All right, let's get started again. And so to find F inverse, I'm going to go through the steps. So interchange x and y is the first step. Now solve for y. I'm going to multiply both sides by 5. These will cancel. I'll get 3y minus 2. And I'll put that on the, just turn it around and get 5x. And then I'm going to add 2 to both sides. And then I'm going to divide by 3. So what we notice is that there was a minus 2. It's now a plus 2. There was a times 5, or times 3. It's now divided by 3. There was a divided by 5. It's now multiplied by 5. But we didn't have to worry about getting this order correct because this process did it all for us. This is the inverse function. Like this. And now we're going to go through something else. And we had done this last week about verifying. Let me just remind you about verifying. If the original function was making something too larger, it could be like somebody's height. You put them in a stretching machine, not very pleasant. Now you're 2 inches taller. And then the inverse of that is a compressing machine. It makes you 2 inches shorter. And if you go through both, you're as if nothing had ever happened to you. And but how do we verify that these two functions are indeed inverses of each other? Well, if you do f and then you do f inverse. Remember, they always go from the inside out. If you did f first, the 7 becomes a 9, and then f inverse chops 2 off from that and gets you down to the 7. And then vice versa, in either order. You could do it, the f on the outside, f inverse on the inside, that doesn't matter. Now here it's done with x. And this, what had happened is the f inverse and f had killed each other off. You were back to the original as if nothing had ever happened. But we might have been lucky with just the input of 7. Maybe it only happens with that specific input. So to really show that they're inverse functions, you have to do it with a general letter x. F of x means adding 2 to it. F inverse means subtracting 2. They get you back to x as if nothing had ever happened. Now, that's what we need to do here. So, next task will be to verify that f of x is 3x minus 2 over 5. And f inverse of x is 5x plus 2 over 3 are really inverses. Now, for you to verify this, the verification is, and you can do this in either order, f inverse of f of x, or you could do the f inverse one inside and the f on the outside. Either order. And what needs to happen is you need to be able to get back to x. And let me give you a minute, see if you can get this to verify. We've done it with simpler functions, but this is pretty complex, but it'll still work out. All the operations should cancel each other out. So let me give you a minute, see if you can get that on your own. So I would leave the outer one there, place the inner one with what it is, and now I'm going to do this function, f inverse of anything is really 5 times that thing plus 2 over 3. And all this is going to go inside the parentheses, in both parentheses. And I'm going to get this all over 3. Okay, now, what if these are really inverses? Everything is going to cancel out and you're just going to wind up with x. But we can't just start canceling everything out because there's a particular order in which we have to cancel. For instance, right here, this minus 2 and this plus 2, we can't cancel them out at this point. But we can multiply this, and so that these 5s would cancel out. These have to cancel first. Now, if I just went right from here into canceling these 2's, it's not showing the order in which I cancel them. I wouldn't be able to tell looking at it later which one happened first. The 2's got canceled or the 5. So the only way to really show that, and that's kind of convenient, is write out the result after this first cancellation. And then do the next cancellation. We can't cancel out the 3's yet. We have to do these next. And then, thus, finally, the 3's will cancel or reduce. And then I get x. And that's as if these two have killed each other off. And it verifies that they are indeed inverses. And if somebody had gone, let me just kind of point out, if somebody had gone, said, these two cancel, then these two cancel, and then these two cancel, and did it all in one, and then said equal to x, I'm not going to give them full credit, because that's not showing the order in which they're happening. But that has a tendency of occurring. Alright. Now, let me give you another function. Alright, B. G of x is the square root of 9 minus x squared with x greater than or equal to 0. Alright. Now, the reason why you're going to have things like x greater than or equal to 0 is, we're going to get into that in here when we look at one-to-one functions in a horizontal line test. So let me just jump down to here for a minute. If f of x is equal to x squared, let's look at this function. It's an ordinary parabola centered at the origin. Okay. Now, this is a function because it passes the vertical line test. But it is not a one-to-one function because it doesn't pass the horizontal line test. Horizontal line test means any horizontal line should hit the graph only once, because the vertical line test says a vertical line can only hit the graph once. Horizontal line test is talking about the same kind of thing but with horizontal. Now, it can still be a function but not pass the horizontal line test. Now, if it passes the horizontal line test, though, then we call it a one-to-one function. Okay? So one-to-one functions pass this test. Any horizontal line will hit it only one time. So this is not a one-to-one function. It fails the horizontal line test. And now, if it fails the horizontal line test, what we usually do is we'll make it pass the horizontal line test by doing something like this. Now, if you say, here's my function, and we're only considering the right half of it, that means it kind of wipes out this part of it. Now, it's passing the horizontal line test. So that's what's happening up here. We'll tell you in a little bit why the horizontal line test is important. But let's go back to this one. So because it had an even power of x, it'll often have something like this. X has to be positive. It doesn't allow the domain to include negative numbers. All right. So now find G inverse of x. So let me give you all a minute on this one. And when you get your answer for G inverse of x, I want you to type it into your group chat. Don't hit enter quite yet, though. We'll give people some processing time. Follow the three-step process to find the inverse function. Okay, go ahead and type in what you're getting so far, and if you're getting something that seems kind of like, whoa, this seems really strange, put that in there. Or I'm confused, or whatever. Talk to your group about this. What you're getting so far. All right, group 5. Can you start me out and just tell me what should I do to start to find G inverse of X? So I've quit reminding group leaders to rotate, but that's still part of their job to tell people who's the spokesman for the day. And I'll call on the group leader or the backup if I don't get any response. So Abigail, are you here? Or Caesar?
Um,
Yes.
hey, can you hear me? This is Daniel. Abigail, her speaker isn't
Okay.
working.
Gotcha.
So I think we got the inverse of g of x is the square root of negative x squared plus 9.
Which is the same thing, right?
Yeah.
Because all you did is turn these two around, and that seems really strange. Could the inverse of the function be the same as the original function? So Daniel, what's my first step? How do I get the inverse?
So I replaced g of x with y, and
Okay.
then I interchanged x with y, and then I solved for x. I solved for y.
So what do you do next?
Oh, okay. I uh, uh, did both x and the function to the second power to cancel out the square root.
Nice.
Um, then I subtracted 9 from both sides. Then I multiplied each side by -1.
Okay.
And then I did the square root for both sides.
Okay. When you multiply this side by -1, it'll look like subtraction, so I have to put extra parentheses around that. And then I'm going to get y squared. And then the square root of both sides. And y equals the square root of 9 minus x squared. And that's the G inverse. It's the same as the original. You can get a function whose inverse is itself. And that sometimes happens. This is one of those times right here. Okay. And we could be asked to verify, but that would take quite a bit of time here. So let's move on from here. Thank you, Daniel. All right. Let's look at the similarities and differences between a function and an inverse function when we look at tables. And I'm going to do this with a really simple function to demonstrate the point, because it's really a profound point. It doesn't take much to see it. Suppose I saw f of x as tripling. The inverse function would be making something 1/3 as long. So multiplying by 3, dividing by 3. Now, when you look at a table of values, here, 0, 1, 2, 3, what do you get? Now, if we look at a table of values here, it'll always be the case. All you have to do is take these numbers and push them over to here. Take these numbers, push them over to here. All you have to do is interchange the x and the y. So 0, 3, 6, 9. And then these go to the other side. 0, 1, 2, 3. And this, you can see this happens on a very simple function, but it'll happen on every inverse function. That the inverse function, the table for the inverse, is exactly the same as the table for the function. The only thing is outputs have been turned into inputs and inputs into outputs. They just swapped places. This column and this column will just swap places, and that'll be it. Every single time. We look at tables, x and y columns, just trade places. Now, let's go back and look. When we were coming up with a foolproof procedure, computationally, this thing got starred because that's where all the work was happening. Solve for y. But another perspective is this. This is theoretically where all the work really happens. When you just interchange x and y, that's the same thing as taking this table and moving the input column to the other side, moving the output column. It's just interchanging the x and y in the table. And when you interchange x and y, that's the only thing that really changed the function. If you have something like this, like if you have y plus 3 equals 4x, and then you subtract 3 from both sides, y equals 4x minus 3. If you graph this one, or if you graph this one, you get the same thing. If you make a table for this function, you make a table for this function, you're going to get exactly the same table. When you're solving for y, it doesn't really change anything about the equation. It just changes the way the equation looks. But this is what we call equivalent to this. The graph of this will be identical to the graph of this. Solving for y actually doesn't really change anything. And then replacing y with f inverse of x just changes the name of one of the letters, but it doesn't really change anything either. The only thing that really changes anything is this. When you interchange the x and the y. That did all the work, and that is equivalent to moving these two table entries around. Okay, so function and its inverse when we look at tables. Now, when we look at graphs, how does this affect a graph? All right, so let's graph this y equals 3x. And we're going to do it point by point. X and y. So one of the points is 1 over, so 0, 0 is one such point, and then 1 over 1, 2, 3 up. There's another point. Now, when we do the inverse function, so these are part of f, and this is going to wind up being 2 over 6 up. It's going to be a straight line like this. When you graph this thing. All right. Now, that's f. Let's look at f inverse. F inverse has a point 0, 0, just same point. But instead of 1 over and 3 up, it has 3 over and 1 up. Now, what's going to be the case is that if you take a 45-degree angle line, now this is the line y equals x. This point right here, which was 3, 1, when we turned the coordinates around, it became 1, 3. Now, what will happen every time when you turn the coordinates around is if you lie on this dotted line, so on the line y equals x was the point 0, 0. That one doesn't move at all. 0, 0, and then the new point 0, 0 are both the same point. If it's on this line y equal x, it doesn't move. If it's off the line y equal x, what we do is we take a line perpendicular to this dotted line. So this forms a 90-degree angle. And we go the same amount in this direction down here till we land at what's called the image point. This point comes across and comes to its image point right here. Now my picture doesn't look very good, but this should be the same length perpendicular over to this one. Okay? And every single one of these points over here, if this was 2, 6, when we take this perpendicular to the line y equal x, extend it the same distance over here, and then we get its image point. Now these 3 points are all a straight line. If we connect them, we get to this. So, when we look at graphs, what we say is reflect the graph of y equals f of x across the line y equals x to get the graph of y equals the inverse function. So this is how functions and inverse functions will be related to each other on graphs. Thus, a little more space here. Thus, if I have now remember they're gonna reflect across this line y equals x. Let me take a function that goes like this. Let's call that f. Let me make my new function the inverse function. F inverse. Well, the only points that didn't move were on this line, y equals x. So it's as if we fold our paper along the line y equals x. If we wrote the original function with wet ink, and we fold our paper along this line y equals x, where the wet ink leaves ink, that's the new function, the inverse. And so, if we folded our paper, folded our paper across this y equals x line, this point doesn't move. This point doesn't move. This part winds up looping over on this side, like this. This kind of comes and stays kind of close to that, while this one kind of goes far away, like that one was doing, right there. Right, let's get rid of that little thing. Okay. And, oops, got rid of too much. Let's delete that. So, what does this tell us? Let's look at something. If I have, let's do another example of taking a function suppose my original function is upward parabola, centered at the origin. Oh, that didn't go so well. Okay. So then, if this is my f, now, when I reflect it across this y equals x, to get the inverse function. Well, what are the points that aren't going to move? Here, and here, and this little thing is going to go like this. This part is going to go like this. This part is going to get folded across. It's going to wind up coming like this. So what happens? is the original function when I reflect it across the line y equals x to make its inverse function. An upward parabola would become a sideways parabola. Now, f is a function. How do I know it's a function? It passes the vertical line test. F inverse is not a function. It does not pass the vertical line test. If there's even one vertical line that hits the graph at more than one point, then it's no longer a function. Well, this has lots of such lines. So it is definitely not a function. All right, in math, what we're mostly interested in is functions. And we want the inverse to also be a function. All right, how do you get the inverse to be a function? This is what I was referring to earlier. What we do is we make the original function f of x equals x squared, but we restrict it so that only the right half of it is part of the function. What that does is it wipes out this portion. Now, when we restricted it, we turned f, which was not a one-to-one function, because a one-to-one function passed the horizontal line test. And this function, in its original form, did not pass the horizontal line test because a horizontal line hits it more than once. What happens for inverses is horizontal lines, when you reflect a horizontal line across the line y equal x, it becomes a vertical line. So if the original function didn't pass the horizontal line test, the inverse function won't pass the vertical line test. So we do this, we restrict the original function so that it's now a one-to-one function. And then when we reflect this one across, it becomes the upper half, and the lower half never got reflected. And so now the inverse is also a function. It passes the vertical line test. All right, so there was a lot of explaining. It's pretty complex. Give me a little feedback. Does this all make sense? Horizontal line test, one-to-one function, restricting the domain so that it passes the horizontal line test, and then the inverse will be a function. Okay, a lot of people confused, need more practice. All right, it's not a big deal in this class. When you go into pre-calculus next semester, if you go there, you'll see more of that. In this class, what you really need to understand is just why they're doing things like this. X is greater than or equal to 0. So that, they're getting rid of part of the parabola so that when I get the inverse function, it will also be a function. Alright, so that's that. And inverses for each problem, find f inverse. And, alright, that takes us really to the end here. So, are there any questions? All right, your homework is 3.7, which is the inverse functions. And because we had gotten a day behind, we're having it now. This is on the exam coming up on Wednesday, so, and it's due before the exam. Also before the exam is practice test number 1 with errors corrected. You gotta upload. You don't have to upload the whole thing. You just upload the problems that you missed with the errors corrected into that upload to get the full 10 points for that. And during the exam, right at the so what I want you all to do on Wednesday is come to the Discord class. We won't be connected via Discord during the exam. I won't be doing a screen share, but have the Discord going during the exam. If I message you via Discord during the exam, then, and I'll do that right at the beginning, I'll message a few people and I'll say we're going to connect for a little bit, maybe 5 or 10 minutes during the exam, and I'll ask you to work out a problem and to show me your work. And that's just to make sure, to give a little accountability, to make sure that people are really doing their own work. The rules on the exam are the same as if we were in class at the community college. You cannot use your textbook, you cannot use your notebook, you can't use the internet, you can't look things up. You work your problems out. You can use a non-graphing calculator, and you can either just work it all out on a blank sheet of paper and then afterwards, take pictures and upload that, or you could print out the test and then in the blank spaces there you can write in the problems and then take pictures of that, upload that. However you like to do that. All right, if no other questions.
Wait, Robert.
Yes.
What do you mean by a non-graphing calculator?
Okay. Let me put my camera on. All right. So this is a graphing calculator, and I can make graphs with this. Y equals, and then enter, and hit graph, and it'll do graphs and so on. And then what's called a scientific calculator that's not graphing. Let me go grab one. Hang on a sec. Alright, I have another one, I just can't find it right now. But here's like a super basic one. You want one more function than this. This has almost like just addition, subtraction. You want like sine and cosine, you want, exponents and all that stuff, but not the ability to graph. And graphing calculators are absurdly expensive. They're like, around $100 or so. But a regular scientific calculator you can get for $15, $20. And that's what works great. And
Okay, thank you.
Yeah, you're welcome. Any other questions? All right, let me stop the recording. I'll see you all on Wednesday.